Hello and welcome to another Ginger Mathematician video where I'm going to go through the key 5 iGCSE mistakes to avoid. And this advice doesn't come from me directly. This comes from the official Cambridge examiners reports from November 2020. I thought I'd share with you 5 key tips from that so you can really improve your grades and try and get to that A and A star. So let's get started. Okay, so tip number 1 is to look for the most efficient method to a question. And this comes directly from the paper 2-1 extended here. So if we actually look at this, it says we need to be encouraged to spend some time looking for the most efficient methods suitable in various situations. And this came up on this specific paper in questions 12 and 20. So let's look at one of these questions and see where you can find that efficiency. So the interior angle of a regular polygon with end sides is 156 degrees. This is one of these trigger words that I do talk about in my videos. If you haven't checked out that video, do check it out above. And we need to work out the value of n. Now, one way you can approach this is use the sum of interior angle formula, but there is a quicker way to do it. So imagine you have a polygon like this, and you're told the interior angle is 156 degrees. What we can do here is actually work out the exterior angle of this, because angles on a straight line add up to 180. So if we do 180 minus 156, that's going to give us 24 degrees. So a very simple calculation to work out the exterior angle. Now the reason this is important is that we can actually work out the number of sides, I've got n sides at the moment, what n is, by using this fact. It's a really simple formula. It's always 360 divided by the exterior angle. So in this case by 24. And if you put this into your calculator, then you'll generate 15, which is the answer to our question. So n is 15, i.e. this shape here has 15 sides. And by doing it this way, you're saving yourself time for those really difficult questions later on in the paper. Number 2 is to make sure you attempt each question, or at least a part of the question, however small it is. And this comes from the general comments from this November 2020 paper. There was a high rate of no response, so absolutely no response whatsoever on the final question, and it seemed to be due to the vectors topic itself rather than the lack of time to do the paper. Now, if you're stuck on vectors generally speaking, do check out the video above. I go through all of iGCSE vectors in about 50 minutes. But if we take this question that they mention here, so question 23, and we read through this, well, B is the midpoint of the length CD, FA is 2 lots of AC, and they want you to find the vector AB, so going from here to here. Now this is a 3-mark question. Even if you're not sure exactly how to split the line up, we can work out some vectors. So for example, you know the vector FC is going to be useful in some way. So you could write down the FC. So how do we go from F to C? Well, we go M and then minus N. So just writing that down could give you one of those marks. Alternatively, you may want to write down the vector CB. That could also be useful for this calculation. And well, CB, well, that's going to be half of FE. So we can write that down. And we know what the vector FE already is here. It's a half M. So I'm not going to complete this question in the entirety, but my key point here is writing down something fairly straightforward that could help you get that extra 1 or 2 marks that could make the difference between one grade or the other. Number 3 is an interesting point to make here. I saw this when I was going through the November 2020 examiners report, is to make sure your numbers are clear, specifically 1 and 7. So you have to be careful how you write these. Now, when I write these in my PowerPoints here, I write 1 as just a straight line going upwards, and then the 7 usually with a line through it here as well. Now, if you come from maybe a European background, you may write your 1s like this. This is quite common, and you can see if you've got a 7 here, they can look quite similar. So if you have an operation, let's just put down a really straightforward question, and I write it like this. Now, in that heat of the moment, in that stress cauldron known as the exam, you may think, this is just a 7, and then do the incorrect calculation. Of course, here we're using BidMaths, we get the answer of 50. So be really careful with those numbers. And a point made towards the end of this as well, when you make a mistake, so say I didn't want to write down 24 pi, I want to write down 26 pi. The idea here is you sometimes write the 6 over the top, get confused with what this number says. What you should do instead, just cross it out, write then 26 pi instead, to make it really clear when you're typing into the calculator to get that right calculation. So there's a couple of points actually within question 3 here. 1 and 7s, watch out, do not mix those up. And if you are going to make a small mistake as you're writing, just cross it out and then write the whole expression again. Number 4 is to know which topics get you the very top grades. So in that case, not using all your time revising the sort of B and C material. Now, the question you're going to ask here is, how do I know which topics are A and which topics are A star? Well, they give this in the general comments in the examiner's report. So if we have a look at this, the most challenging questions, the most challenging were the ones involving standard form, bounds, differentiation and vectors. Those are the topics that are going to make the difference between an A and an A star, or a B and an A grade. If you need any help with this topic here, differentiation, then do check out the video above. I go through this again in about 50 minutes like vectors. And the last part is avoid rounding in calculations too early, and this also continues into inappropriate rounding as well. So make sure if you are rounding, it is for the appropriate reasons. So if we have a look at the examiner's report here, this was particularly evident in the bounds question of this paper, which I'm going to have a look at now. So this is the question here. So we've got the sides of an isosceles triangle, important phrase to know what that means, are measured correct to the nearest millimeter. One side has a length of 8.2, another has a length of 9.4 centimeters, and we want the largest possible value of the perimeter of this triangle. Now with these kind of upper lower bound questions, I would again definitely sketch this out. Now remember, isosceles means that two of the sides are the same, and we want the longest sides to be the same. So we're going to put in 9.4 centimeters here, 9.4 centimeters here, and then 8.2 centimeters here. Now we need to have a look at each of these individual numbers and work out the upper bound for each. So if we take the 9.4s here, what's the highest number that would then round down to 9.4? Well, we know 9.45 would round upwards, everything less than that would round down. So our actual bound here will be 9.45, because everything below that will round downwards. That's going to be the same for both of these. And if we do a similar process for the bottom one here, so I put it over in black, that's not very helpful. So we'll take out 8.2 here. And if we again get the highest bound here, we're going to get 8.25. Now you're probably thinking, where does this 0.5 come in? But it's going to come in now. So if we want to work out the largest possible perimeter, so largest, well, we need to add these together. So we have two lots of 9.45, and then we add 8.25 to it. Now if we do that calculation on the calculator, we're going to get 27.15 centimeters. Now the problem here, and this is what a lot of students have done, they've gone, I've got my answer here, I always need to round to 3 significant figures, and then they put 27.2 centimeters down. However, this is wrong. They want the precise largest possible value. So in this very individual case with bound questions, you need to put exactly that number down as your final answer. That's really, really important. So if you look at the mark scheme for this question, it's really worth looking at this. You'll see they use this phrase CAO. Now this means correct answer only. So you could lose a mark even though you put down your final answer as 27.15 before rounding it. You could still lose it because you said 27.2 is that final answer. So really watch out for this. You need to round appropriately, and this is a classic question where actually having this to 4 significant figures or 2 decimal places is actually the correct answer and what you must write down. Those are the key 5 topics to look at. If you really need to review the very hardest questions from this course, then do check out the video in front of you, because I go through as many hard questions as I can in about an hour to really make sure you're ready for those A and A star questions.